So in this video, I want to talk about one of the example of SAT math problem, and the question is which of the following equations represents a line that is parallel to the line with equation y is equal to negative 3x plus 4. And if you look at our function, it is clearly a linear function as we have learned in the last few videos. The linear function is a function that raised the first power of the variable, which is x in this case. So if you look at our questions, there are some choices right over here. And before we solve for this question, let's think about it in terms of our function of this question. So let's think about in terms of a function of this question. And for the function of this question, as we have learned a lot of times, it will going to be y in this case. And for the function y, it sometimes contains its factor bit, but this is a case where it doesn't. And for the function, it contains a specific equation, which will going to be negative 3x plus 4. So it will going to be negative 3x plus 4. And if you think about in terms of systems of function, it always requires a specific input. The input is a value that we put into our variable, which will going to be x in this case. And for that input, there will be a system of function. After there was system of function, there will be a specific output. So there will be a specific output of the function. The output will gonna show us as the value of y. So that means the line, I'm going to call it line because this is a linear equation. And a linear equation is a equation that if we graph it, it will going to be straight line. But the straight line will going to be based on this equation y is equal to negative 3x plus 4. So I'm going to talk about it later. And if you think about our function y is equal to negative 3x plus 4, the question said it is parallel to that question, to that line. So if you think about it, our question, the question says it is parallel to the line with this equation y is equal to negative 3x plus 4. So I drew some parallel lines that are formed by equations. And those are parallel lines. And if you analyze this functions right over here, and it is also based on our function property, that the parallel lines should always, their slope should always be same, but that should have a different y-intercept, which in this case, this function has 6 as y-intercept. In this case, they have 3 as y-intercept, but they have a same slope. That means if they have the same slope and the same, if they have the same slope and the same y-intercept, they will going to be something like this that has same equation. But in order to move this, in order to be parallel, they need to move somewhere down, but the slope of this function should be same, but they should have a different y-intercept, so they should be parallel. And this is the case that we learned according to a function property. So we can see that the parallel, so if you write it down, parallel means they have slope are same, but different y-intercept. So different y-intercept. So if you think about in terms of our equation, y, so y is equal to negative 3x plus 4. The slope, which will going to be, if you analyze the basic format of a linear function, it is y is equal to mx plus b, and this is our form of linear function. So it is a form of linear function. And if you think about this function format, the b is a y-intercept, and m in this case will going to be a slope of this function. So if you just use this property to our equation, to our function y is equal to negative 3x plus 4. The slope, which in this case negative 3, should be same, but that should have a different y-intercept. So we figure out that the equation, the function y is equal to mx plus b, one of our choices right over here. The slope, which is negative 3, in this case should be same, but they should have a different y-intercept. But if you look at our choices, they are not are made with y is equal to mx plus b form, which means we need to convert into y is equal to mx plus b form in order to figure out the answer easier. So at first, if you look at our first choices, a 6x plus 2y is equal to 15, we can write that down here. That's 6x plus 2y, and that is equal to 15. And in order to isolate the y term in the left side, all we have to do is subtract everything or add every stuff in the left side and send it to the right side, which will turn into, if you do it, it will going to be, if you subtract 6x to the both side to isolate y term, then we get 2y is equal to negative 6x plus 15. And now we need to make y, all you need to do is convert y's coefficient into 1. So all you have to do is divide 2 to the both sides to get rid of 2. And we get y is equal to negative 6x divided by 2 is negative 3x. And the positive 15 divided by 2 is positive 15 over 2. But if you look at our original form, which is y is equal to negative 3x, negative 3, which is our slope of this function, is exactly the same. And also they have a different y-intercept, which means this answer is correct. So our answer for this question will going to be A in this case. So we can write A. So we have figured out our answer, and first thing what we did is we analyzed how the function works, the systems of function, and through our graphs we figure out that the slope should be same, but they should have a different y-intercept to be parallel on the xy plane. And also we figure out the answer y is equal to negative 3x plus 15 over 2, which our answer was A. So let's think about in terms of graph of this function. The reason why I'm doing graph is because if you go to more advanced SAT math function problem, it's hard to solve for it if you don't really know about the graphs of it. So we actually got that answer that our answer for this question was A. And this was a question that can be solved really fast if we figure out our property about the parallel two functions on the xy plane. That parallel means the slope are the same and they have a different y-intercept. But I'm going to draw a graph in order to prove this parallel thing through our two functions. The reason is because if you go to more advanced SAT math problems, similar with this problem but more advanced one, if you don't really know about our properties, it will gonna take a long time to solve it. So at first, let's think about our graph of our function. Y is equal to negative 3x plus 4. So y is equal to negative 3x plus 4. And I want to write one more function down. Y is equal to negative 3x plus 15 over 2. So y is equal to negative 3x plus 15 over 2. The reason why I wrote both of our functions is because I want to graph both of them so that we can figure out if they're actually so parallel. So before we graph it, if you look at our function, if there's a fraction such as 15 over 2, it's hard to graph it, so all we have to do is convert it into our easier number. So 15 over 2 just means 15 divided by 2, which can be simplified as 7.5. So we can replace 15 over 2 as 7.5. So what I'm going to do is at first draw a graph y is equal to negative 3x plus 4. So if I write it down again, y is equal to negative 3x plus 4. Before we calculate for our coordinates, we know one thing that according to our y is equal to mx plus b form, we know that b, which is our constant, is a y-intercept. In this case, a constant is 4, which means 4 is a y-intercept. Y-intercept means the x value is 0. When the x value is 0, y value, which is a output of our function, will going to be 4. So we know 1.0, 4, so we can graph it. When the x value is 0, the y value is 4 right over here. So this is a case where coordinate is 0, 4. And let's think about one more point to graph. So at first, let's simply think about when the x is equal to 1. When the x is equal to 1, we will get y is equal to negative 3 times, instead of x value, we inputted value of 1. So it will going to be negative 3 times 1, and then plus 4. So we can simplify negative 3 times 1 is negative 3 plus 4 will going to be positive 1. So when the x value is 1, the y value is also going to be 1. So if you graph it, it will going to be, when the x value is 1, y value is 1, right over here. So it is a case where the x is 1 and the y is 1. So if you graph a straight line, it will going to be something that look line that look like this, that passes through our 2 points. And this line right over here is based on our equation. Function y is equal to negative 3x plus 4. So we can write our function down. Y is equal to negative 3x plus 4. Let's think about in terms of our second function. Y is equal to negative 3x plus 7.5. So if you write it down, it will going to be y is equal to negative 3x plus 7.5. So before we calculate for our coordinates, we can know one thing, that 7.5 is a constant, which means it is a y-intercept. Y-intercept means the x value is equal to 0, and the y value in this case will going to be 7.5. So we got one coordinate, so we can point it on our coordinate plane. So when the x value is 0, the y value is 7.5. So 1, 2, 3, 4, 5, 6, 7.5, between 7 and a 5. So it will going to be 1, 2, 3, 4, 5, 6, 7 right over here. And it is a case where the x value is 0 and the y value is 7.5. And we need one more point to graph actual function. And let's simply think about when the y value is equal to 0. When the y value is equal to 0, we will get 0. We replace y value as 0. And that should be equal to negative 3x plus 7.5. All you have to do is isolate the x terms by subtracting 7.5 to the both sides. And then we will get positive 7.5 in the negative 7.5. We're going to cancel out, and we will get negative 3x is equal to negative 7.5. In order to find the value of x, we can divide negative 3 to the both sides. And then we will get x term negative 3 in the negative 3. We're going to cancel out as 1. And then we get x is equal to negative 7.5 divided by negative 3. Negative turn into positive according to our addition and subtraction property. 7.5 divided by 3 is positive 2.5. So when the y value is equal to 0, our x value will turn into 2.5. So we can actually graph that there's 1, 2.5 right over here. It's a case where the y value is equal to 0 and the x value is equal to 2.5. So if you actually graph that function, it will going to be something like this. So it will going to be something like this, and this function is based on our y is equal to negative 3x plus 7.5. So y is equal to negative 3x plus 7.5. And if we just eyeball these functions, we can figure out that both of them are parallel. So y is equal to negative 3x plus 7.5 is parallel to a function y is equal to negative 3x plus 4. So we actually proved that these functions right over here, that our the slope are the same, but the different y-intercepts are parallel each other. So we actually proved that. And in this case, right over here, we just figure out through just the approximate value, but we actually proved that the same slope with the different y-intercepts are parallel on the xy plane. So for our solutions, we can write it down. At first, we figure out that our slope, so the case when they are parallel, that means the slope are same, but they have a different y-intercept. So they have different y-intercept. So this is the main point that we figure out when it comes to solving for this kind of question. So only thing we need to remember is that the parallel just means the slope of this function, in this case negative 3, are same with both of them, both of their functions. But that should have a different y-intercept, so they have a gap between them.